See this question, question number 5, square root of 1 minus 4x minus x square is there. Now this quadratic expression we can change it to completing square form. Now I'm going to take this 1 minus 4x minus x square. I want to take minus common, then x square plus 4x minus 1. Am I right, students? Can you hear me?
Yes, sir.
Yeah, this you can change it to completing square. Look at here. A square plus 4x can be written as 2ab. If I take a is equal to x, a square plus 2ab. What is b value here? 2 square. Shall I write 2 square minus 2 square minus 1? Yes. So still here, like a square plus 2ab plus b square. This can be written as x plus 2 the whole square minus 5. But when I multiply with minus at last, 5 minus x plus 2 the whole square. Now, so what shall we do? In equation 1, from equation 1, we can replace 1 minus 4x square root of 1 minus 4x minus x square by 5 minus x plus 2 the whole square into dx. Right, students? See here, this 5 I want to write as, now let us take equation 2. Okay, we may write directly also. Instead of that, I want to take like x plus 2 is equal to t, then dx is equal to dt. This x plus 2 I want to take as t. When I take x plus 2 is equal to t, x becomes dx, 2 derivative 0, t derivative dt. Again, substitute these values in equation 2. I is equal to integral square root of 5. 5 I want to write root 5 the whole square. Shall I write like this? Now this is t square into dx value is dt. So what do you observe? First, what I have done? I'm taking quadratic expression. I make them to completing square. So that expression become 5 minus x plus to the whole square. Replaced the value. Then I'm taking x plus 2 is equal to t. Then dx is equal to dt. Then I replace it in terms of t. So 5 I have written root 5 the whole square. Since if you observe here, it is in the form of root over a square minus x square dx. What is the formula for root over? Yes, students. This is equal to what? X by 2 root over a square minus x square plus a square by 2 into sine inverse x by a. This is the formula. With help of this, I is equal to x by 2, nothing but t by 2 root over a square, that is 5 minus t square, plus a square, that is root 5 the whole square by 2, sine inverse x by a, that is t by root 5, plus c. Here a value is root 5, students. X value is t. Now we have to replace t value at last. At last I want to replace t value. T value is what? X plus 2. T value is x plus 2 root over this 5 minus x plus 2 whole square, in the sense, remember students, given expression, like what is the given integrand? Given it is 1 minus 4x minus x square. You can write directly 1 minus 4x minus x square, right? And plus 5 by 2, square root get cancelled, 5 by 2 sine inverse of x plus 2 by root 5. Let's see, this is the required answer. Once again, equation 1, I have taken the quadratic expression, I make them to completing square. 1 minus 4x minus x square value becomes 5 minus x plus 2 the whole square. So I replaced it. Again I am taking x plus 2 is equal to t by substitution method. Differentiate on both sides, dx is equal to dt. I substituted all over, but if this 5 I have written as root 5 the whole square, because there is a formula for a square only, not a. So it is in the form of a square minus x square. I have written the formula and I substituted a value. That's all. So remaining questions and all you can try, students. You have to try yourself. If you want to note it down, you can note it down. See, for example, your eighth question is there. There is no constant. What shall we do here? X square plus 3x. This x square plus 3x alone, you can take x square plus a square plus 2ab. 2 into x into, shall I write 3 by 2? Now 2 get cancelled, again we'll get 3x. Am I right, students? Am I right? Fine. So now if I compare here a square plus 2ab, b value is 3 by 2. 3 by 2 whole square minus 3 by 2 whole square. Still here, this can be written as x plus 3 by 2 whole square minus 3 by 2 whole square, like that. Same again here, x plus 3 by 2 is equal to t. First change it to completing square, this value. Remaining all the question, you do the same procedure. Yeah, what is the answer for question number 10? Anyone? Question number 10. Directly it is in standard form. What is the formula? X by 2, okay. First x by 2. There is no x by 2, wrong. No x by 2, wrong. So here x square by 2, it is wrong. The answer option A is right. First one is x by 2 root over a square plus x square. A square by 2. A value is 1 here. 1 by 2 is log. This is not x square by 2. Wrong. Coming to the next one. Okay, x minus 4, x minus 4, x minus 4 they have given. Okay, fine. This is same or. So what do you observe here? A square by 2. A square by 2. What is a square? That is only the question. It may not be x plus 2. Okay, I'm going to take that expression again. X square minus x, 8x plus 7. X square 2ab, 2 into x into 4 plus 4 square minus 4 square plus 7. I'm adding and subtracting with 4 square. This is x minus 4 the whole square minus 16 plus 7 minus 9. So that is nothing but what here? This can be written as 9 can be written as 3 square. So a square by 2. In the formula, in every formula, a square by 2 is there. Here 3 square by 2, nothing but 9 by 2 should come. Is there any 9 by 2? Yes, the last option alone. This is absolutely right. You can go through the general procedure. What I'm telling here, how to identify directly. Just find a value, a square by 2. Okay, this is just 9. Not, there is no by 2. Like that, you can do this. D option is correct. Any doubts, students? Change it to completing square form. Remember, only 3 formulas are there. Only 3 formulas. That is also very easy. Now coming to the definite integral. I'll explain you what is the mean by definite integral, and there is a fundamental theorem of calculus is there. Second fundamental theorem of calculus. With the help of second fundamental theorem of calculus alone, we are going to find the definite. So this is actually belongs to limit of a sum. See, students, here in revised syllabus, there is no 7.8, not in the syllabus. This is belongs to limit of a sum. This is important for OBT, but they deleted in NCRT. Let's go for the next one. Yeah, after this, fundamental theorem of calculus. Okay, actually, what is the use of what is the difference between definite integration and indefinite integration? Now we'll start a definite integration. Definite integration. Fine, students. So till now we have studied about just integral f of x dx, right? Okay, in that case, here we got some answer. Like let us take f of x, and we are adding plus c. Okay, let us consider this integral value as capital F of x. But now in definite integration, we are going to find the integral f of x dx value between the limits like a to b. A to b. This is can be written as f of b minus f of okay. Look at here. We are getting the output is f of x plus c from where to where a to b. Now here the thing is, what is the procedure here? Substitute upper limit. So here a is called the lower limit, and b is called upper limit. A is called the lower limit, b is called upper limit. Then I is equal to, now substitute upper limit. First always try to substitute upper limit. So right in place of x, f of b plus c minus upper limit minus lower limit. So f of a plus c. Understood? F of b plus c minus f of a plus c, because first upper limit, next lower limit. CC get cancelled here. So remember student, the formula is f of b upper limit minus lower limit. Clear students? Yeah. Once again, I'm going to explain you that definite integration. Definite integration means like we are going to get a particular value. In indefinite integral, we should take plus c. We don't know exact the value, but here we'll get a particular exact value between the limits. So what is the use of this? To find the area of the curve in given region. See here, we want to find the area of this curve y is equal to f of x between a to b, because you know the curve may exist like minus infinity to plus infinity, they may exist, but we want to know just area between two particular values. I'm taking x is equal to a here, x is equal to b here. Between these two values, we need to find the area. Between this x is equal to a to x is equal to b, we need to find the area. Right. Fine students. So here integral a to b f of x dx means the meaning is the area of the given integrand between from a to b. X is equal to a, x is equal to b. Okay, we have to find the area between these two ordinates. Okay, we have to draw the vertical line at x is equal to a and x is equal to b. Okay, it will meet the given curve at certain point. So here if I take a, b, c, d, this area of a, b, c, d is given by integral a to b f of x dx. That's all. Okay, so in that case we'll get the area. So here we have defined integral a to b f of x as the area of the region bounded by the curve y is equal to f of x between the ordinates x is equal to a and x is equal to b and x-axis. Let x be a given point. Okay, x belongs to closed interval a comma b. Then integral a to x f of x dx represent the area of light shaded region. Nothing but okay students. So this again I'll explain in the properties of definite integration. This like split into like here properties, integral a to b can be written as like integral a to c plus integral c to b. This is one of the property. This is nothing but what, for example, I want to find the length from uh, Salem to Coimbatore. In between, E road will be there. I stopped at E roads. Like we can divide the two part like Salem to Coimbatore, at Salem to Erode, Erode to Coimbatore. Finally, we can reach Salem to Coimbatore. Okay, to find the length, to find the area, to find the volume, we can use integral, applications of integral. Okay, applications of integral. Okay, if we evaluate only the given integral, in higher studies, we are going to study about double integration and triple integration. A triple integration is useful for finding the volume of the given curve, dx, dy, dz. Here f nothing but f of x comma y comma z. F is a function in terms of x, y, z. Here actually we have to find the triple integral. With respect to x, we can keep y, z are constant. Like that, some pressure will be there. If you find this triple integral, you are going to get volume. And if you find the double integral, you are going to get area. Indefinite integration, and if you take single integral, we are going to get length of the curve, right? Area of the curve, volume of the curve between some ordinates. Okay, that let us see later. So here this is about definite integration. But the thing is, the problems are very easy actually. What are the problems? Whatever the problems are there in next exercises in definite integration, compared to indefinite, this is easy. Look at, for example, 1 by x is the 2 to 3. Second question, I is equal to integral 1 by x dx is there from where to where? 2 to 3. See, and also students, whenever you observe that, always they may give in the question least value in as a lower limit, least value as a lower limit, highest value as a upper limit. Upper limit is highest value, and lower limit is least value. Compare here 2 to 3. How to read this? Like 2 to 3, integral 2 to 3 1 by x dx. Integral a to b f of x dx. In the same way here, integral 2 to 3 f of x dx. Fine. This is answer. See here, just forget about the limits. Forget about the limits. Now what about the integral here? Integral 1 by x. Shall I write this value as log x from where to where? 2 to 3? Yes, that's all. Don't think about limits. Just integral 1 by x dx is log x. From way to way 2 to 3, 2 to 3. First you can say that least lower limit is 2, upper limit is 3, 2 to 3. So this is equal to substitute. What is the pressure? Upper limit minus lower limit. Substitute 3 in place of x, then after minus, substitute 2 in place of x. So log 3 minus log 2. Okay, that is log 3 by 2. Log a minus log b formula is log a by b. That's all. Okay, 1 by x integral is log x from 2 to 3, log 3 minus log 2. Nothing but upper limit minus lower limit. That's it. And you can take any question, like for example 6, 4 to 5 e power x dx. Integral 4 to 5 e power x dx. Yeah, what is the e power x integral amount? E power x from where to where? 4 to 5. So e power 5 minus e power 4. So this is the answer for this question. First, don't think about limits. E power x is there. E power x integral is e power x from where to where? 4 to 5. First, in place of x, substitute upper limit minus lower limit. Upper limit minus lower limit. That's all. This is the answer. Let us see one more question, like for example 10th question, 0 to 1 dx by 1 plus x square. Yeah, what about the formula? Just forget about the limits. This is directly standard formula. This is clearly tan inverse x from right, students. Now 0 to 1, substitute upper limit. What is tan inverse 1? Pi by 4. minus 0. That is pi by 4. Got it? Tan inverse 1 is pi by 4 and tan inverse 0 is 0. Yeah, I'm going to give one question to students. All of you try to do that. For you, the question is, yeah, question number 8. Can you able to do this? Directly integral cosecant x is there. Question number 8. Do it fast. Students, just I have given only one question. Anyone completed? Students, what about the doubt clarification section today, whether for B1, B2 or the section C? Today continuously classes. Okay. Yes, students. What is the answer for this cosecant x? This is directly formula. But the question number 15 alone, we can do the substitution method. This is directly formula. This is directly standard integration, standard integration, standard integration. Okay, what is the integral of tan amma? Log mod secant x from where to where? 0 to pi by 4. For example, these questions they have given in objective. Like see here, log of secant pi by 4 minus log of secant 0. Log secant pi by 4. What is secant pi by 4? Root 2. Am I right? Minus log secant 0 is 1. What is log 1 value, Amma?
0.
0. So log root 2 can be written as 2 power 1 by 2 minus 0. So 1 by 2 log 2 is the answer. Otherwise, log root 2 is the answer for this question. Tan x. Okay, next I'm going to do like, okay, fourth or fifth question. I'll do it. Let us do the fifth one. Otherwise, you can do the fifth one. Just uh, integral cos 2x is sine 2x by 2. From where to where limits 0 to pi by 2. Substitute upper limit in place of x. Substitute lower limit in place of x. This is equal to 0 will get, okay, fine. Next, cosecant. Cosecant x answer is what? Integral cosecant x into dx. Pi by 6 to pi by 4. Yeah, what is the formula, ma? Cosecant x?
Log of cosecant x minus cot x.
Yeah, log of cosecant x minus cot x. From where to where limits? Pi by 6 to pi by 4. Okay, now substitute upper limit. Log mod secant x secant pi by 4 minus cot pi by 4 minus log mod secant pi by 6 minus cot pi by 6. I substituted upper limit and lower limit. Yes, here log mod secant pi by 4, 45. What is secant 45? Root 2 minus cot 45, 1 minus log,
Sir, it is cosecant mostly.
sorry, cosecant. Even cosecant also same value, but write it cosecant, right on. Here pi by 6. What is cosecant 30?
2.
Minus cot 30,
Root 3.
root 3. So log a minus log b. Log root 2 minus 1 by 2 minus root 3 plus c. This is, so not plus c. It is a particular value. So no need to take plus c here. Once again, it is directly standard integration. Cosecant x is log cosecant x minus cot x. Log mod cosecant x cot x. So just replace x by pi by 4, that is upper limit, minus p plus x by pi by 6, lower limit. Upper limit, lower limit. Just I substituted that cosecant 45, cosecant 30, cot 45, cot 30, and I simplified. This is the required answer. That's it. Yeah, I'm going to do the 15th one here. 15th one. Okay, because 15th one it is related to substitution method. Remaining questions, okay, easy. Limits from where to where? 0 to 1. Question number 15. Right. Students, here we cannot apply UV rule. Without limits, already we done the same question in indefinite integration. What we have done in that case, let us take here x square is equal to t. 2x dx is equal to dt. X dx is equal to dt by 2. Okay. This is about x square and dx. Shall I take like this? I have written x is here. So now, so fine students. Whenever you apply the substitution method, many of the students forget to change their limits. Okay, here What about this limits 0 to 1? Is it x limits or any t limits? Are these x limits or t limits? These are the x limits. So dx is there, nothing but x is equal to 0 to x is equal to 1. dt will be there, t is equal to 0 to t is equal to 1. dz will be there, z is equal to 0 to z is equal to 1. Like that you can take. Okay, yes, here what is the condition here? Condition is t is equal to x square. Am I right? X square is equal to t, nothing but t is equal to x square. Now, when when x is equal to 0, what is t value? 0. When x is equal to 1, what is t value? 1 square. That is 1 only. Okay, nothing but when x is equal to 0, t also 0. When x is equal to 1, t also 1. Here in this question, limits are not changing. It's not like that. Okay, for example, if the limit is 0 to 2 will be there. When 2 square becomes 4, 2 square becomes 4, like that. So in this question, here we are getting the same limits, right? Same limits we are getting now. So now I is equal to integral 0 to 1, like t is equal to 0 to t is equal to 1, e power t x dx, that is dt by 2, 1 by 2 times of e power t is e power t from where to where? 0 to 1. 1 by 2 times of e power 1 minus e power 0, that is about 1 by 2 e minus 1. Right, students? This is the answer. Once again, here I have taken x square is equal to t, then differentiated 2x dx is equal to dt, x dx is equal to dt by 2. Fine, we have to change the limits also. When t is equal to x square, when x is equal to 0, t also 0. Yes, 0 square. X is equal to 1, substitute here. T also 1 square is equal to 1. 0 to 1 e power x square e power t dt by 2. So 1 by 2 you can take outside e power t from 0 to 1. So e power 1 minus e power 0.
Sir, here if we get 1 and 0 same value means can we directly substitute in x square, sir? Like x is equals to 1 and x is equal to 0.
Where here it is directly.
Yes, sir. Can we substitute directly there, sir?
No, no. How can you evaluate this integral value? What is the integral value of this e power x square into x?
No, sir. Okay, sir. Got it, sir.
Yeah, yeah. Before applying the limits, we should evaluate this indefinite integral value. It's not possible. We have to apply UV rule. Even if we apply UV rule also, what is the e power x square formula? It may be derivative, it may be. So integral is what? Generally derivative, okay, we'll do it with help of chain rule. E power x square is e power x square is 2x. But in integration,
Okay, sir. Got it, sir.
okay, right. We should convert like e power t form. Okay, student, finally, this is the answer. Having any doubts, you can ask. Yeah, let us take another question. When you see this question number 18, it's easy. 0 to pi sine square x by 2 minus cos square x by 2. I is equal to integral 0 to where pi sine square x by 2 minus cos square x by 2 into dx. Okay, so here in this question, I want to take minus common 0 to pi cos square x by 2 minus sine square x by 2. This is becomes what, students? What is the value of cos square minus sine square? Cos square plus sine square, it is 1. But cos square minus sin square. What is cos 2x formula? Shall I take cos square x minus sin square x? Yes, there is a formula. With help of this formula, cos square x by 2 minus sin square x by 2 becomes what? 0 to pi. Yes, shall I write this value as cos x into dx? Okay, cos 2x is cos square x minus sin square x. Cos x is cos square x by 2 sin square x by 2. Yes. Now, this is clearly sin x. From where? Where to where? 0 to pi. Okay, now minus sin pi minus sin 0. Sin pi, sin 0. But here we are going to get 0. Sin 180 is 0, 0 minus sin 0 is 0, 0. What is the answer they have given in the book back? Yes, students?
0, sir.
0, I think. Am I right? They would have given 0. Am I right, students? Okay.
Yes.
Right. This is the, so here first we should know the formula. What is cos square minus sin square? But in the question, sin square minus cos square is given. Take minus common. Then this has become cos x. Cos x integral is plus sin x from 0 to pi. Next, any other question? This is easy only. See, 2 secant square is tan x. X cube is x power 4 by 4. 2 is 2x. From where to where? Then 0 to pi by 4. That's all. Secant square integral is tan x. X cube is x power 4 by 4. 2 is 2 into x. Substitute upper limit minus lower limit. That is the answer. No issue. Question number coming to 13. 13, look at here. X square derivative is? What is x square plus 1 derivative? 2x. Am I right? So multiply and dividing with 2. So it is like f dash of x by f of x. So log 1 by 2 log mod x square plus 1. Now apply the upper limit and lower limit. That is 2 to 3. Once again, x square derivative 2x, 1 derivative 0. Numerator we having just only x is there. X we required 2x. Right, Amma? We require 2x, so multiply and dividing with 2 here. So it is like the derivative of denominator is in numerator, so it can be written as 1 by 2 log mod denominator. Now this is the integral value of this. So now 2 to 3. Apply the upper limit. So 1 by 2 times of log upper limit. 3 square plus 1, that is 10, minus log 2 square plus 1, 5. So 1 by 2 log 10 by 5, that is log 2. 1 by 2 log 2 is the answer. Coming to this question, for example, take 21. See straight direct, it is a formula 1 by 1 plus x square. Formula is tan inverse x 1 to root 3. Apply the upper limit. Tan inverse root 3 minus tan inverse 1. Tan inverse root 3 is, students, 60 degrees. This is 45 degrees. This is 15 degrees. What is the 15? 60. This is 120 here. 30. This is 15. Option D is right. Only the thing is integration is very, very easy. At the same time, every year, mostly the students are asking the more number of doubts in integration alone. I don't know why. Because they are not practiced at the same day. See here how much it is easy. Like they'll asking that they asked that, okay sir, in what how to identify whether we can apply substitution, whether UV, whether partial, this kind of question they asked. By seeing the question itself we can say directly whether it is will do directly, or else we can apply the partial fractions, we may apply UV rule, or we may use substitution. I told you very clearly 60 to 70% of the question based on substitution. Remaining 40% is like substitution and sorry, 40 partial fraction, UV rule, reduction formula, like that.